Hello, welcome to the 99th edition of Airhacks TV. I think the first time at Sunday, and I thought about this, and maybe Sunday is better than Monday. And I thought, why I never thought about that. And the reason is, usually before the pandemic times, I was always on the road on Sunday evening. So on the road to my clients. And sometimes, Monday I was back again. So this is the reason. But actually, Sunday would be not as bad. But back to the topics or questions. First question from Ondro, and Ondro is not just someone who asks questions. Ondro was a guest on the Airhacks FM podcast, and if we take a look, this was the episode 160. And Ondro questioned my attitude about modules back then, and we had a nice conversations about modularization. Andre is his name, and he works for Payara. And so let's go to the question right away. And so also interesting, he listened to the episode, or he enjoyed the episode with Goran. And this is even more interesting because let's take a look at the where is I just prepared that. This is the episode with Goran Opacic, and the interesting part is Goran attended the Airhacks at Airport Munich a few years ago, and then he just implemented some Java EE and J2E stuff, then went to the cloud, and I think we didn't met for years. And I just found him on Twitter again and pinged him, and we recorded the episode together. And the interesting part is, without knowing about each other for years, we actually had very similar architectures. This was the interesting part, and we talk about that during the podcast. What's also unusual is Goran is the owner of the company. And so we could really talk about the architectures, which is unusual for me, because usually I'm working as consultant and I have to sign NDAs everywhere. So usually I'm not allowed to talk what I'm doing. But in this episode, we had we could actually talk what Goran is doing, and which I really enjoyed. Okay, so now back to Andre or Ondro's question. He enjoyed the episode and asked me, you mentioned there's Jersey adapter for AWS Lambda. And also says, I know Azure provide GMS API for Service Bus. On that note, if you go to Airhacks FM, I actually interviewed the product managers from Microsoft about that. And they implemented a highly compatible version of, where is it? Wait a sec, there's way too many episodes about Microsoft. Yeah, this is this episode 111, and we talk the entire hour how the GMS on Azure Cloud is working. But now back again to the question. And Andre asked me, do you know any other Jakarta API supported by cloud services? Not only the whole Jakarta EE, but also individual APIs. And this is longer answer because the Jersey adapter for AWS Lambda is different. What it actually does is it makes Lambda look like an application server. This is what I really enjoy. So what the Jersey adapter is doing, it is receiving HTTP events and dispatching them to JAX-RS endpoints. It means my AWS Lambda serverless project look exactly like projects you saw in the recent 90 episodes in Airhacks TV. So they look like, a lightweight Jakarta EE or MicroProfile applications, and they are working really good on Lambda. And I'm using Quarkus for that, and Quarkus receives the events. And for me, it looks like Java EE with minor limitations. Like limitation is, it's like Java EE, a single process Java EE, single process request scope Java EE server on AWS Lambda. Now, regarding the other GMS API, so obviously MicroProfile config is well integrated because I'm able to inject the environment entries from Lambda, so I can configure Lambda with CDK. and inject the properties. And what's also integrated is the JSON Web Token, because if the HTTP API gateway send us HTTP token, then it can be understood. JMS I never use in the cloud, and the reason being is, but I don't think it is worth of doing so. So if I use JMS, I always use the JMS 2.0 or 2.0 JMS context. So I was able to send and receive JMS messages with one line of Java, which I enjoyed. So it looked like CDI events. And sometimes even I encapsulate the CDI events, or I send CDI events, which was propagated via JMS. In the cloud on AWS, I use SDK directly, so I'm not relying on JMS. So what it means is if I have to send something to a SQSQ, I'm just using the SDK, and if I would like to send a topic, I use SNS or Kinesis, which is similar to Kafka. Or you can even use Kafka, but what I prefer is I prefer Kinesis, SQS, and SNS over Kafka in the cloud. Why that? Because SQS, SNS, and Kinesis, they come with HTTP endpoints, and what it means is it is easier to set up. Easier to set up means this will be a longer discussion. Easier to set up and easier to secure, because it is enough to use IAM policies, and it just works out of the box. Also, you don't have to care about pooling, security groups, and stuff like that. So I would say SNS and SQS and Kinesis are serverless solutions, which means I don't care about the infrastructure. I can just provision a topic or a queue with a single liner, where if I would use a typical JMS server, the first question I will ask you is know how to set up the topics and queues. And as you probably heard already here on this program here, JMS is nice if it is set up, but I'm absolutely not interested in the administration of JMS servers. Okay, so first question answered. I hope Andre is happy. And then Andre asked me, what do you think is a place for Jakarta EE and AWS Lambda and other commodity cloud services? Does it somehow, can it be helpful, or is it overkill to use Jakarta EE and plain Java, JDBC, and so forth? So what I really like is the new API called Jakarta EE Core, and I plan to talk about that in Jakarta EE live stream conference or Jakarta One conference. We Java developers, we are in a unique position, because what we can do is we can write larger, maintainable, apps, which will run as AWS Lambda, and so save money, be less complex than tiny lambdas which communicate with each other, and just use stock boring technologies like Jakarta EE. So lean code, no interfaces, no factories, it's just code to the point. And with Jakarta EE, we even get the hexagonal architecture goodness, because we are completely abstracted from all the exactly. Let's talk about AWS Lambda. If we receive HTTP event from outside, this HTTP event gets automatically processed by JAX-RS, and JAX-RS receives the event and does something and passes it to us, and we are just not aware at all that actually HTTP API gateway got the event, and it was passed to Lambda. Lambda as JSON. Lambda parsed the event, was passed to Quarkus, and Quarkus parsed the event and invoked JAX-RS. Okay. Now, so I think it is the future is bright, but more like writing a small microservice and not trying to decouple or to encapsulate the cloud services. What I truly believe is, if you would like to be efficient and productive, you should use on AWS, and on Azure services. If you try to encapsulate the entire thing, exactly the same circus starts what we had 5 years ago, like with the DAOs and decoupling and multiple layers without any benefit in vast majority of all cases. So our next question from Andre. If you build an app based on AWS Lambdas, how do you package all things together? Just by keeping on the same repository? Okay. So what I do is this is Maven, and then the Maven projects comprises multiple lambdas, and it depends which one. If the lambdas are asynchronous, you can do this. So you have multiple lambdas which in one repository. So what it means is I ship the same repository several times, and the lambdas are. It would be similar to have how we call it back then, share nothing architecture, I think. So what I did back then is some projects I had exactly one war, and I could actually ship this war multiple times and activate and deactivate services depending on customers' needs. The same what we're doing in Lambda. So we have one zip. This is shipped multiple times, and in the zip are, let's say, 10 lambdas, but each time another lambda is picked. So this is like still monolithic Maven. So if you know me, don't expect any parent POMs. Nothing is very simple. And in the case of synchronous Lambda, it's Quarkus-like HTTP API gateways. It's a little bit different because the Quarkus registers as a generic Lambda, and there's only one, which is enough because this Lambda, which is registered, actually can expose multiple JAX-ORS endpoints. So it can be a mid-range applications. In most cases, such Lambda applications have several hundred Java classes, so it's more than enough. Okay, yeah, thank you, Andre. And what we could do, if you like, we can set up a podcast if the viewers of AHXV are also interested. And Andre, you can ask me this question. We can have a conversation, in the podcast. So just about that. Okay, next question from Andre. Connection pooling in AWS Lambda. Long story short, it doesn't work. So you have multiple Lambdas and multiple processes. You shouldn't pull the connection. Or at least, the connection in Lambda is actually pulled because it's frozen and then reactivated. So it works until the next, cleanup. And then we get a cold start again, and then the Lambda is called again. So what it means, this is one of the reasons why in the Lambda case, I don't try to use connection pooling or, JDBC connections. What I would try to do is I would try to find HTTP endpoints in the cloud. And for instance, there's a product called Aurora Serverless V1. And this V1 comes with, I think it's called Data API. This is the crazy part. It is available for Java as well. It's not JDBC, but you can access Postgres via REST. And then you don't have to care about connection pooling. And this is not available in V2 yet, but I expect it is going to be available because there is no reason not to have it. And also, it's a little bit problematic with, I would say, whenever you have proprietary binary protocol in the cloud, it's problematic. Kafka is problematic, JDBC is problematic, native JMS is problematic because usually you would like to pull the connection. The next story is, the next question is how to secure the connection and so forth. Recently I had to send email. So there is a service called SES, the same story. And you can use, your SMTP, or you could use web service, actually SDK, to send email, which I would prefer because I don't have to care about pooling. Okay. So is RDS proxy is the best solution, but Andre, you already are expert. What RDS is actually, what reminds me about is, I remember Oracle, it was like at least 10 years ago. PHP became more and more popular, and what Oracle offered is pooling for PHP applications, connection pooling, because the PHP applications couldn't pool the connections. So Oracle did it for them in a kind of a proxy. The same is RDS proxy. So this is additional component which does SSL encryption and connection pooling. So how this works is it just multiplexes the connection. So it is getting better. So you can achieve higher scalability. But again, the best would be to use the data API. On that note, we are talking here now about nice things, but fact is, in the cloud, the architecture is not dictated. Whether something can be encapsulated or not, it is dictated by the actual costs. And if you consider the cost of relational databases, I would say a mid-range database, you will pay roughly 1,000 euros a month. So you can go, with the serverless options like Aurora V2. So the smallest installation is 40. This is like half a CPU, I think is 1 gig RAM. A month you will pay 40 euros, and then you can scale up, down, but never to zero in the V2. In V1, you can scale to zero if you actually like it. And so what it means is it is actually also expensive. So what I would consider first in the cloud, just to save costs, is to use something like DynamoDB or even S3, which is crazy, but it looks like Java hash map. And for particular applications, you can achieve a lot. So it's not like I'm saying, the DynamoDB and S3 are nicer than JPA. No, JPA is more convenient than SQL. Everyone likes SQL. But if you can save multiple thousand euros a month, then it could be interesting, right? So, and this is what happens in my projects. We are not only talking about nice APIs. A costs are a factor, and if I explain it to my clients, they change their minds. What we can do in the cloud. So on premise, complete different story, because no one cares about costs usually. You have to pay for the server. What runs on the server, no one cares. So I will pay the same for Cassandra as for Oracle, I would say, on premise. In clouds, no, because let's say DynamoDB, the first million invocations are free. So if this is no low frequent application, you will pay nothing. If you get more invocations, so you will pay per invocations, but then it becomes transparent. You can say, look, this is an interesting use case or important use case. Every call cost us so much money. Or let's say a use case like the Payara, because or the enterprise support for Payara, because Andre, I think, is working for Payara, and will take us, I don't know, 100 DynamoDB transactions. Will call us, let's say €1 is not true, but let's assume €1. But a Payara support contract, we will, have a revenue of €2. So still okay, right? Okay. Now, so what's interesting is this time is like a cloud AirHexDB. So all questions are cloud related, which is interesting. By the way, I have to check. Oh, we have lots of here. So Brett Tucker, friend of the show, of course, his glowing wine is legendary. Then we have Mr. Java Guru, I think, is Mr. Kulkarni, and works better for him. I think he also enjoys Sunday. And Jeff Rogers, he attended the last AirHex Live, I guess. So I met him in person and really enjoyed. Hopefully, Jeff Rogers also enjoyed our workshop, which was unusual. It was a workshop countdown. So what I actually did is, it was the first time in history I deployed, I don't know how many examples, but a lot of examples to AWS. And then undeployed them one by one and explained how they are working. So it was not like coding show, it's more like, countdown to zero show. Okay. AWS Hero, yeah. Thank you, Anbu. I have, thank you. Someone had to nominate me for the AWS Hero thing. So thank you to you all for the nomination. I think how it works, I have no idea. I also don't have no idea yet what AWS Hero means, but thank you all for nominating me. And what I joked on Twitter is, it is enough just to write simple Java code and everyone gets excited. So any full stack GitHub repo with web components with Jakarta EE to replace JSF. What you probably know is I have the BCE design. Where is it? Let's say this is, I think, my GitHub account, and there is BCE design repository. BCE, this user. BCE design, and this is used a lot, and this is independent from the application server. What you can very easy do, you can pick, for instance, my mockend Jakarta EE or MicroProfile applications, put it on Payara or whatever, and this web components will talk happily to whatever you have in JAX-RS. So there is no need to couple web components with Payara. Regarding web components, in one of the subsequent podcast, I have a guest who is actually a Chrome developer by Google. And we have a chat about web components, why they use just web components, which is interesting. So, and Goran Opacic. So this is the long friend of the show, and also AirHacks Munich attendee. We had lots of fun with Goran, and he runs a company entirely on AWS, and he migrated the company. And by the way, just a spoiler: what Goran did, he performed, I think, the biggest deadlock in the history of AWS, and became hero for that reason. So you have to listen to podcast to hear that. Okay, now okay. So where are we? So this was my take on that. So I would say JDBC and JMS matter less in the cloud. And why this? Yeah, because all the JNDI, I would say cloud is more like exploded application server. And if you take a look at JMS context, as I said, and you compare it with SDK, SNS or SQS, they are very similar. So I would say there's no real added value. Where Java EE shines is the dependency injection, and you can use bin validations and whatever is usable inside the microservice. Jakarta EE core APIs are golden for AWS Lambda. Anything else is optional. Yes, and Goran, he joined the chat. So Ondro, if you're also in the chat, you can have a conversation with Goran and say thank you to Goran for the podcast and his time. Okay, now another friend of the show, Felix Müller, cloud person, asked me, I always enjoy your recommendation migrating some workload to plain Java Lambda on AWS. So thank you. And what struck me, actually, I started with it. Maybe I started with this I would say 2019 maybe, and no one talked about that. And then on Twitter, the people say, okay, this is interesting that you talk about Java on Lambda, that they didn't even thought it is possible. And it works surprisingly good in my case. So also interesting story, a large enterprise company, and they had migration strategies from Java EE to the cloud, and they considered Kubernetes and all the crazy options. And I told them Lambda would be actually interesting because we can just migrate straight from Java EE to Lambda. And they told me it's impossible. And then I showed them that it's possible. So they asked me say, okay, we did knew that it's possible. Can you write something, because it's priority number one, to show we can save costs, and is really interesting option. So I would say it's somehow Java is under the radar, and if you show this to clients, good stuff happens, which is great for me, because I can sell the old code again, which I show you for 15 years. The last 100 episodes as from AirHacks TV, I can package it again, ship it as AWS Lambda. Everyone is happy, right? So that's the strange thing. Okay, but now back to the questions. You ask me, what's the downsides of tired compilation, and what it does under the hood? So the tired stop at level 1, this is my understanding, means that the Lambda only optimizes for the C1, and no more for C2. How it is called, collector. This is not the garbage collector, the C2 compiler, of course, not collector, compiler, C2 compiler. So what it means is the Lambda starts faster, but is less optimized. Now the question is to know what it does under the hood. Okay, this is what it does under the hood. I think you are asking what is the downside of that. So, but I will proceed with this. So I never did this. Why not? Because what you could do is the cold starts become a little bit faster or less problematic with that. What you lose is the optimization during the runtime of the Lambda. Now the question is how frequent the Lambda gets invoked. Let's imagine you have one invocation, and then every minute the Lambda is invoked, so the Lambda remains hot. The longer the Lambda runs, the faster it gets. The more you deactivate at the beginning, desto faster the cold start, but less performant the subsequent invocations. So it means if your Lambda is invoked once a day, the best possible option would be maybe GraalVM optimization, because you can minimize the cold start, and you will lose some performance optimization at runtime, but no one cares, because every call is probably or is for sure a cold start. If your Lambda is invoked more frequently, I would do nothing, because I would rely on Java internal optimizations, and you will actually save money. Back to provision concurrency, I think you're asking. So it's also a really interesting option, because what provision concurrency means is that one Lambda instance or one thread is going to be kept hot or warm, and all subsequent invocations will hit the Lambda, and you have to pay for it. But there is a threshold. So if there's a lots of traffic, it may be at the end of the day even cheaper than without the provision concurrency. So my opinion is do nothing, write simple code, measure, and see, what's your target? Would you like to optimize, for money, for costs optimization? Is it a cold start optimization, or is it a runtime optimization? And there are also some interesting hacks. For instance, we have MicroProfile health. Oh, forgot this to Andre. MicroProfile health, right? So Lambda could expose health endpoint, which I always do. It doesn't make any sense, because the Lambdas, this is also interesting. 99, I say I always expose health in Lambda, but it doesn't make any sense. So it doesn't make any sense from the health perspective, but I misuse the health endpoint as additional metadata information. And what you can do, if your Lambda is running behind the load balancer, let's say, what you can do, you can say, hey, load balancer, invoke the Lambda every 5 minutes. And the load balancer will check the health of the Lambda and keep your Lambda warm, which could be even cheaper than the provision concurrency. But there's only one Lambda. So if you get 100 requests at the same time, one Lambda is warm and all the others will be cold. So the Lambda cold start is problematic for maybe for Goran software, where you can have a public endpoint which with unpredictable load. For my projects, enterprise projects, no one cares whether once a day a user gets have to wait 1.5 seconds until something happens, right? Okay, Mr. I hope we discussed this. Then Omega 09. By the way, really nice name. Ask me. We are developing a system where mobile devices send their location frequently to a Java EE server. The device sends the location 5-10 times a second. So the question would be, how many devices do you have? It's also interesting. And he asked me what I will do, UDP or whatever. So for this purpose, the first question is, are you running in the cloud or on-premise? If you run on-premise, actually, raw Kafka could be an interesting option for you, because Kafka will receive, will store all the events to the application server. Then you could use Quarkus MicroProfile reactive messaging. So you can receive the messages and send them back to another Kafka topic, and this Kafka topic could be mapped to WebSocket. So actually we did such architectures, and it worked surprisingly well. So you don't have to use Quarkus. You could use Payara, also works. It doesn't matter. It is called. You have to search for small reactive messaging, I think. Yes, I agree. Exactly. And what the small reactive messages does, it will is more like JMS with Kafka. You will receive the message, and then you process the message. And if you send the message to a Kafka topic, you can have another listener which reads the Kafka topic messages and translates them to a SSE or WebSockets, let's say. So this is what I will look into, is to Kafka, and I wouldn't experiment with UDP too much. So on the in the cloud, what I'm thinking about such a thing, I would use Kinesis. This would be my first choice, because also Kafka, you have to manage Kafka, and it becomes expensive. Even the serverless option of Kafka is I would say more expensive than Kinesis. I compared several times for my use case. You always do your own calculations, but Kinesis is very similar to Kafka. So Kinesis in the cloud, and Kafka or Pulsar, but Kafka is more popular on premise. And then take a look at small reactive messaging, and I think this would be the most scalable and robust architecture. And even if you could linearly. If your topic, think about this. If you create a Kafka topic, create enough partitions. Every partition is a thread. 100 partitions, you can consume the messages with 100 application server instances. Okay, this is what we already did in production. It worked well. Not for devices, but actually with web components, and it worked really well. Mr. Amar Dempile, can you give us some recommendation for security protection for Java or Quarkus applications? Okay. What you would like to do is denial of service attacks prevention, it looks like. And so, on-premise, what I already saw, you could use bulkheads, and I'm not sure about retry, but with bulkheads and asynchronous, this is what you could do. With bulkheads and asynchronous, you could have one thread pool per endpoint. And endpoint and thread pool per endpoint, you can have a bulkhead, so you can restrict the amount of parallelism per endpoint. This is very, I would say, very simple implementation of that. In the cloud, HTTP API gateway, let's say, there is a throttling built in, and the algorithm, I think, is called token buckets. Token bucket. Yes, token bucket algorithm. And I already saw the token bucket algorithm implemented on premise in CDI. So yeah, but you're right. I would use bulkheads with asynchronous on premise first. In the cloud, I would use HTTP API gateway, for instance. And for denial of service attacks, I would this HTTP API gateway is a partial solution. Web application WAF is a better. But I mean, better. In one point of time, you have to talk with support, with AWS support, or you could use third-party solution like Cloudflare, for instance. But if you are under heavy load, this is like lots of IP address, blacklisting or whatever. So it's not like there is no magic in DDoS, I would say. But what's interesting, if someone tries to DDoS you, it costs money for the other entity. So in one point of time, they cannot just generate, a huge amount of load for free, except, they have a bot network or whatever. But this costs them money or a risk, to be uncovered. So the question is, how much do you like to invest to protect yourself from DDoS? Okay, token bucket. Take a look at this. Interesting algorithm. Okay. I hope I answered your question. Then Mr. Felix Müller with interesting W7T2A acronym or handle. I want to deploy API service with Quarkus Helidon to AWS. So Helidon, as far as I know, Helidon, there was an issue that Helidon wanted to implement the JAX source adapter, but I think it's still not available. So you cannot do with Helidon the same stuff what you can do with Quarkus. What you can do, you can use Micronaut. Micronaut comes with similar support to Quarkus. And by the way, at the December edition of AirHacks, there was an attendee of the AirHacks Live workshop, and he wrote a book about Spring Boot, and he migrates now from Spring Boot to Micronaut because he say Micronaut has more similar APIs to Spring Boot. And all the other attendees were more interested in Quarkus. So if you are running Spring Boot applications, maybe Micronaut is you like Micronaut more. What I know is Jakarta EE and MicroProfile developers really like Helidon or Quarkus a bit more. And yeah. And now he asks, okay, do you have a recommendation way to prefer Docker container instead of Lambda function? My choice is Lambda function, and not because what you're asking, splitting or not splitting. So if you say container, first you can run, you can package, the entire stuff in container run in AWS Lambda, so this still works. But you cannot just run, even if you run something like Fargate, which is the most serverless option on Fargate, you will have to have an VPC. You have to decide how many availability zones you would like. So you have to create 2 or 3 subnets with CIDRs. You need one CIDR for the VPC. Then you have to think of creation of S3 of the VPC endpoints. Then you need some security groups. Then you have to create a Fargate container. You have to create a task, a service, a target group, and a load balancer, and maintain certificates, and usually Route 53 a record, which points to the Fargate. But if you use Lambda, you create a zip, ship to a Lambda, and just to try things out, you can use function URL, which generates DNS. You are done. No VPC, no subnet, no additional costs. Or you can have HTTP API gateway with throttling and certificates management and version management and routing. Or you can use load balancer, which for higher loads is better. And load balancer can even provide authentication for you. So I would say I would go with Lambda first because it's less infrastructure involved. And it is true serverless solution. What means by serverless is you will see in the invoice how often the Lambda was invoked and how much it costs, or how many gigabyte seconds. So you can translate it to invocations, but you will see, how much cost the Lambda incurred. Okay. And it's also okay to use Panache when using Quarkus in Lambda to access RDS, or should I prefer plain JDBC for query my database? Absolutely. So you don't have to use JDBC. You can use absolutely Panache, but why Panache? I would use JPA. So for me, JPA is perfect. So Panache is like a simplified JPA. So if you like Panache, go with Panache, but JPA is absolutely fine. If you what you have to do is, if you have Lambda, connection pool with setting of 1. So if this is typical enterprise application, I don't expect, let's say more than 500 concurrent connections, right? So then you get 500 database connections, which is usually fine for this purpose. You don't need RDS proxy, nothing. It will just work. And what you can do, you can restrict the concurrency in Lambda. I think it's called max concurrency on the CDK level. Maximum concurrency, something like this. Not provision concurrency is the max concurrency. I forgot, but there are two flags. Okay, now Felix Müller again asked me, if you want to use identity management, something like single sign-on or OpenID Connect, which runs in Lambda function, do you have a recommendation here? What fits well in serverless stack, or what do you hear in your projects? Okay, two possibilities with Lambda. If you need authentication, let's say you have nothing, greenfield, you are alone, then the best choice is AWS Cognito. And it comes with user management and identity pools and user pools. What you're searching for is user pool. User pool is a user management, basically, so you can create your own users. And then HTTP API gateway will authenticate against Cognito, create a JSON Web Token. JSON Web Token is passed to Quarkus. And Quarkus, you can use MicroProfile JSON Web Token, decode the token, and then you are golden. And if you don't have HTTP API gateway, you can use ELB. This is actually, ELB supports exactly the same. It supports OpenID Connect Flow. So the HTTP Elastic Load Balancer can authenticate against AWS Cognito, create the token, and pass it to Quarkus. So I would use either ELB or HTTP API gateway. So when to use what? You have to pay for ELB the entire time a little bit, but under a heavy load, it is cheaper. And HTTP API gateway costs you nothing for the first 1 million invocation, and then costs you something. So go to cost calculator and do the calculations. Now, something interesting happened. So I was actually hit by a marketing company, which I usually reject, but I know the guy is really nice. And he said, okay, I know you from earlier. We've worked together, and now I'm working for a marketing company. And then CEO of an interesting company would like to talk to you on your podcast. And I said, okay, but I don't like such things. But it was an interesting interview with the creator of Pulumi. And why it's interesting to you? Because I use a lot of CDK, but there's also Pulumi. And Pulumi came with Java. This is what we had a chat with Java support. And how they implemented it, this is really interesting. So Java talks to Go via gRPC, and Go talks, to AWS using CDK, and sorry, not CDK, SDK, Software Development Kit. So this Pulumi is a little bit faster than CDK, but looks very, very similar. It's very lean Java solution with 2 dependencies. But still, I keep doing CDK. It's the official AWS, solution. But Pulumi is really interesting. If you have a multi-cloud environment, Pulumi, you don't not only implements supports AWS. You can also ship to Azure, and CDK is just AWS. What also Pulumi comes out of the box is state management. So they are pushing all the state to your account. It is Terraform. You have to configure something at the beginning, and Pulumi is pre-configured, and this is less chatty. And I also recorded a screencast about that. Oh, by the way, this is lucky accident. December the 15th, there will be AHEX Live online workshop, just about persistence. And actually, all the questions you asked me today, I wanted to cover, or already will cover in the workshop. I actually forgot what the agenda is, but you see connection pooling with RDS proxy and AWS Lambda, and you can check this. Actually, the agenda is fairly old, a view month at least, or weeks. No, view weeks, no, month. And I will gather all the questions and extend the agenda. So I'll try. What I will do is I will cover serverless relational databases, then DynamoDB, S3, and maybe a little Kinesis. So let's see how much time we'll get. So okay. So this is the Pulumi. So this is how Pulumi looks like. So it's really lean. So I just created a bucket. But not only a bucket, this is our website. So I was a little bit more ambitious during the screencasts. So this is the public website bucket, and actually shipped a small HTML page live, and the entire screencast was like 9 minutes from scratch. Okay, Pulumi. So what it means is, now before you write thousands of lines of Terraform, now you have 2 choices: CDK or Pulumi, which is both are really nice. And both are Maven. So we talk about, so if you like, join the persistence. I am thinking about messaging as well. So, but persistence is coming, and there are already sufficient registrations, so this workshop will take place. And podcast with Andre. So this is his background. If you would like to know what was the first computer from Andre, go ahead. And this was the 99th edition of AHEX, and wow, is it new one? New question? Lots of questions. Wow, fresh questions. Com.Linux. Com.Linux is Mr. Web Components, Quarkus, and Graal. This is the Java guru. He told me I can, but I still don't understand why there is a Python enthusiast. So as far as I know, Python is a language where you need a really good formatter, otherwise it will break. And somehow Python is related to YAML, so it's very suspicious. This was a joke, not that, Okay, now, when you're running Fargate, so this was 1 hour ago, so if the server is always running, does it cost a lot? 32 gigs of RAM, 4 CPUs cost you €180 a month. This is what I know in Frankfurt, because I'm doing this for my client. And this is actually a big installation. Would you say that compilation with Graal VM is only option when you have quick cold startup time? I mean, the cold start comes in 2 phases. The first phase is like creating the entire environment, and the second phase is launching Java. And with Graal VM, Quarkus starts in 5 milliseconds, so you can reduce that, but it will still you will have take half a second or 300 milliseconds for a cold start. What I forgot to mention is about the cold start. It's not like you're paying for the cold start. So if you're evaluating this, go to CloudWatch and search for build. and you will see build duration, whatever, and this is what you're paying for. So even if the cold start is, let's say, 3.5 seconds, usually you will build, you are going to be built for, I don't know, 1.5 seconds, something like this. Is the only option. So is the way to have a, let's say, small server. But by the way, on Fargate, there's no cold start on Lambda. So if there is, or the cold start on Fargate would be auto scaling. So it's just like, there's not enough load, and you see the CPU is going up, and then a new instance is provisioned. This was improved, but the cold start on Fargate is, I would say, minute right now, and it was 5 minutes back then. Or is it a way to have let's say, a small server that is running elsewhere that immediately spins up one Fargate service and then scales up as, you don't have to have the server running because it happens automatically. It's called auto scaling on Fargate. And there are several policies. The most interesting one for you is maybe target tracking policy. It will, you can say, I have my own metric, and the metric is, let's say, MicroProfile metric, amount of orders per second. And if there are more than 5 orders per second, I will automatically scale another node. So it happens automatically. So it's not a problem to configure this. It's a more problem, of test it and whether it works as you expect. And CDK can do it absolutely. So I could do this. I don't like to confuse you with that. By the way, if you go, also news, I forgot to mention this, I think, the last time. Let's see. So this was the web component. This was JMS. These are the questions. This is the interview with Joe Duffy from Pulumi, how Pulumi happened. But this was really interesting interview because Joe has also some Java background. So he is a Java developer. He really likes Java. And Joe also worked on Microsoft, was involved with Windows development. So I think you will enjoy the podcast, this one, about Java and Pulumi. And really nice guy, Joe. So now, this example, AWS Quarkus Lambda CDK plane, I forgot to describe, so the README is not up to date, but what it already supports is it supports an AWS Lambda on Quarkus with function URL. So this is the cheapest solution, but not with custom DNS names. It's just function URL. So it is directly exposed the JAX-RS endpoint as a DNS entry publicly. HTTP API gateway, which is the cheapest and modern solution. REST API gateway, which is not legacy, but it fades away, but it's still more powerful than HTTP API gateway. But in one point in time, you could replace it completely with HTTP API gateway. And it also ships with the load balancer ELB support, which is not even documented in Quarkus. So what I did is it was an issue, and I pointed to this example because the issue says Quarkus does not support ELB, and it works. So in this example, I could absolutely add auto scaling, but my feeling is this example is already too complex because usually what I expect is that you take this example and decide for one solution and delete all the others. So I don't like to create and all possibilities here, because at the end of the day, someone will look at this and say, hey, Java is too complicated. We have to go to Python, to have small lambdas. Okay, so this is also covered. So looks good. So Java Guru again. Also another request with AWS CDK. Is it possible to use path routing with a single application load balancer to route a request to 2 services running in a single Fargate cluster? This should be simple. I mean, with a single application load balancer to route a load balancer. So load balancer means you will need 2 target groups and 2 listeners and a path routing. I think this should be simple. Because what we already did, we have different routes for health and for the application. You tried with HTTP listeners and routing, it should be actually work out of the box. So there is nothing, I would say this should be simple. Maybe you tried with something different. As I remember, the routing is implemented on HTTP listener level, and it should work out of the box. Okay, then Mr. Jeff Rogers. Hello, welcome back. Is there a cost-effective solution for JPA in the cloud that is Jakartaistic? Actually, if you don't have a lot of load, use the enterprise system, you can have absolutely AWS Lambda with a standard connection pool as Quarkus, one connection only, and it works perfectly. You don't need. It's just the simplest possible solution. Then what I would suggest, if there's not lots of load, you can ship Aurora RDS V2 with a half of ACU. ACU stands for Aurora Capacity Unit, and half ACU will cost you roughly 40 euros a month, and it can scale up to but there's 32 or I don't know. No, 128 I think is the upper limit. And what an ACU is, I think one ACU is 2 GB of RAM. So and this would be Jakartaistic. Jakartaistic means deploy a zip and you are done. And the very last question, 20 minutes ago during the show, I would say the show will never end. If you keep asking questions during the show, it will never end by definition, right? I also used your CDK Lambda project to create a simple Lambda that uses Quarkus, but without native compilation. It does not start but around 5 seconds. It actually starts in 3.5 seconds. So interesting what you did. Maybe you should increase the RAM. I'm not sure because I think the initialization runs in one CPU, and the example what I showed you, it is recorded. It starts in above 3.5 seconds is the cold start. It should also start in your environment in 3.5 seconds if it is Quarkus. Native compilation, I don't have a repo, but I think I even did it live for Java User Group Switzerland, I think. I don't have it, but I could do this, but I don't do it in production. So this is the reason why I'm not doing this. The question is, why there's a problem for you? Even if it is let's say this is 5 seconds. So if the application is not that frequently used, then no one cares, right? Because once a day, if someone calls your method, who cares? And if the application is frequently used, then it happens maybe once. And then if you have load balancer or HTTP API gateway, you can have health checks. And with the health checks, you will never ever get a cold start for single-threaded Lambdas. On that note, I think we are done. Let's check what the chat is going crazy. So okay, we have. Yeah, John says Quarkus has the Spring compatibility APIs. I know, but the Spring Boot people still. I mentioned this actually in the workshop, and the Spring Boot people still preferred Micronaut because I think Micronaut is so. Mr. Graham Roche was the origin creator of Grails. By the way, it is also, of course, covered in our Airhacks FM podcast. And the Graham Roche said that he created Grails, which was inspired by Spring Boot, and he joined Spring Boot, was a committer, then was not fired, but the entire department was fired, and then he started Micronaut, and at Micronaut is very similar to Spring Boot, and this is why Spring Boot people prefer Micronaut. But of course, I use Quarkus all the time, and I like Quarkus a bit more, I have to admit, because it is less, fiddling with the annotation processor. So this is less magic on build level. So what I prefer a little bit more. So the magic is within the extensions, and in Micronaut the magic is in annotation processors. And yeah, and I'm MicroProfile and Glassfish and Payara and Whitefly and OpenLiberty developer. So Quarkus fits a little bit better, and Micronaut doesn't ship with full MicroProfile support yet. So, John Klingen again. John, you are not right. So, John, I am disappointed right now. John says, it's not just about startup time. Native compilation runs with less memory, reducing cloud costs, which is not true at all, John. I know it for sure, because to my knowledge, in all clouds. So if you have my Lambdas looks like microservices more or less. So there are a couple of Java classes behind JAX-RS. What you usually need is one CPU. I mean, to have a reasonable, performance, because usually something happens in the Lambda. If you would like to have one CPU on AWS, you will have to give the function 1.8 gigs of RAM. So 2 gigs of RAM. So Quarkus in my current projects with several hundred classes consumes 300 megs RAM. So what it means is we actually have plenty of spare RAM. We cannot use it, but we have to buy it in order to get more CPU. To my knowledge, the same happens on Azure. Not to my knowledge, I know it because I also did the same on Azure Functions, exactly the same story. And even Oracle, I think, does the same. So in order to have more CPUs, you have to buy more memory. The problem we have with Quarkus, not problem, the Quarkus is very efficient with memory, but we have too much memory in the cloud, right? So what is true, John, if you would run on EC2 machine, then maybe you can buy a smaller machine, but still the memory is usually coupled to CPUs indirectly, right? Okay. So, and John, by the way, you are invited to the AXFM podcast. We have to schedule another date. So it was just a glitch in our schedule, but the next time it will happen. So thank you for listening. We are exactly 1 hour. So it was, you saw how much, I planned the show to have exactly 60 minutes. And thank you all for watching. And I would say, see you next time in the summer, right? The middle of the summer. And yeah, thank you a lot. Bye.